Hello everyone, welcome to my channel. This is Bhoopesh. Hope you're doing perfectly well on this Sunday evening. So, what we're gonna talk about today? So today we're gonna talk about another interesting session on Kubernetes interview questions that are really asked in DevOps or Cloud Ops interviews related to Kubernetes. So let's see how many questions we can cover in today's sessions. Right. So let's see what is Kubernetes. I think most of the people know, but still it's an orchestration tool. It helps you to manage, schedule, and you know uh, manage scheduler applications into the cluster and keep them running smoothly across the cluster of machines. Okay, this is a quick Kubernetes architecture that you see. I'm not going to talk about control plane. There are four different components of control plane that you can see in my detail another session on Kubernetes architecture. But these are the worker nodes where we deploy all our applications. Worker node one, worker node two, and this is a master control plane that handles everything, and from where you put all your CLI commands. This is the user interface. Next question: what is the pod? Interesting. Pod is a logical unit of one or more containers. So pod can contain one container, pod can contain multiple container. You see this pod 2 contain one container, pod 1 contains three containers. So pod is a logical unit that encapsulates and that shares a Docker containers that share same network IP, can communicate via localhost, and can share storage volumes across containers. This is a small snippet of a pod. You see API version v1. The kind is pod. This is the metadata name. Spec is about how many containers it can contain. So containers is this is the first container. I'm calling a image redis, and these are the environment variables. So this is a normal YAML of a pod. Now, what is a container? Interesting. Container is a tiny virtual machine that is very efficient, just like a virtual machines. It runs only your app and its dependencies. It shares the host kernel system, making it faster and lighter than a full virtual machine. This is a snippet of a container. Same photo, but this is the container I'm talking about. So pod is a logical unit, container is a smaller child unit, and we can have multiple containers at the same level inside a pod. Next question: what is deployment? Any question, any answers? So deployment is simply a high level object that manages and decides the number of pods. So basically, it's an automation to deploy your pods into the environment, and then you can containerize your application. You can help to do rollbacks, updates, scaling, and self-healing of applications. So you see, client is deployment, and doing these are the match labels. Is replica one means I'm telling only one pod for this deployment, and this is the container. So I'm saying please create a pet clinic container or a pod with the help of this deployment. So deployment is a family of a pod and container manifest. Next question: what is the service? Interesting. Service is helpful when you want to hit the endpoint with a particular port from a pod, and the service one service can communicate to multiple pods, and it actually holds the single point of contact for a multiple pods, and it is handled with the help of labels. So if any pod has a label of app equals to pet clinic, then service will be created, and that service will run on port number 80, all right, which will ultimately go to target port on 8080. So stable IP DNS name, it is helpful for doing load balancing between multiple pods, decoupling between front end and back end components, watches all the matching pods using labels as I mentioned. So a service can communicate with pods with the help of labels only. Forwards traffic to one of the healthy pods. If you have three pods and one of them is healthy, then a service will forward the traffic to that healthy pod. Keep communication consistent even if pods comes and goes. So that is the beauty. So you need to just define the service, and if your pod is getting deleted and everything, service will take care of that communication. Next question: what is a stateful set? Interesting question. Stateful set is a Kubernetes controller, which is normally for your stateful application. I'll show you an example of stateful set like MySQL DB or a Postgres. So stateful set is a manifest that holds you in this container contains all the volume mounts, basically file system that is used to run this application. It can be MySQL or Postgres, or and for this this file system is being mounted by persistent volume and persistent volume claim. I'll talk about that thing in the next set of questions. But persistent volume is something a dedicated claim. It has taken a 5 GB of claim in the VM, and the PV will get the claim from that PVC. Right. So in short, you just remember the stateful set is a controller that helps you to do the uh, persistent storage, and it is responsible for stateful applications. Next question. Popular question: difference between deployment and stateful set. So yeah, so deployment and the stateful set difference is really straightforward. It is for stateless applications. For stateful applications, randomly generated pod names. It has a properly serially generated pod identity, not preserved. It has a unique sticky identity, meaning the request will be served by that pod, particular pod. Storage is optional, but it needs a dedicated persistent storage per pod. DNS names not guaranteed, but it's a DNS stable DNS names. Startup shutdown order, no order, but it has order 0 1 2. You have seen that. Scaling behavior, all can be created at once, but it creates one at a time. You might have seen the stateful set pods comes one at a time. Rolling updates, all pods updated in parallel, but here in the case of stateful set, it goes one by one in order fashion. Volume claim, no volume claim, but it has a unique persistent volume claim per pod. Examples: web servers, APIs, front-end apps. But in this case, it's MySQL, MongoDB, Kafka, and so on. Next question. What is pod monitor, service monitor? Yeah, pod monitor and service monitors are the Kubernetes custom resource definition defined by Prometheus operator, and they helps to monitor the particular service. In the case of service monitor, monitor the particular pod in the case of pod monitor. Now you see the snippet. Define the service monitor. I'm saying please monitor my service which has a label called as app my app, and it will monitor that service, and it will take the endpoint of HTTP metrics from that service and take the matrices data basically. So it's a CRD developed by Prometheus community. Next question: how to schedule a job? You might be having a lot of things in your mind. How to schedule a job? So you can definitely have a cron job the way you schedule in Linux, because ultimately you want to schedule your job into the Linux worker node. So how you can do it from Kubernetes? So there's a cron job kind with which you can set up any particular job or a particular schedule. It will run the same command, same every 5 minutes. You see the echo hello from cron job will run on a busy box container in this cron job, and you can see the logs. It's easy peasy. There's another client called as job that we'll talk about later, not a cron job that you can run on it only once. So cron job is for multiple executions, and job is for single time. Next question: what are probes? It's interesting question. So probes helps you to check your container is really ready for traffic, whether it is restarted or is ready to accept requests. So there are three particular important probes. Liveness, if the container is still running. Readiness is the container is ready to receive the traffic, and the startup probe is whether the container has been startup or not. Next question: steps to upgrade the cluster. Very important and popular ask in an interview. How you upgrade a cluster? So basically, first of all, you back up your etcd and cluster config. You drain the control plane node. Important thing. You upgrade kubeadm. Then you upgrade your kube control plane. Then you upgrade your kubelet and kubectl. Uncordon the node. The repeat for each worker node. Right. This is interesting question. Problem that my favorite also. Problem that you see while upgrading clusters. You might have seen the deprecated and removed APIs. This is a very important key aspect before you upgrade any cluster. So if you are moving from 1.28 to 1.30, you need to see what are the incompatible APIs that has been deprecated or has been removed. And if those APIs have been used in your Helm charts, make sure you're upgrading your Helm charts that are supported in the next version. That is a very important update that you need to see. Kubelet and kube proxy version mismatch. Yes, you need to see this network plugin or CSI driver incompatibility. Sometimes you see this problem whenever you do cluster upgrade. So you see this problem also before you do version upgrade. Next question: what is the secret? Very simple. Secret in Kubernetes is an object used to store sensitive data such as passwords, API tokens, SSH, TLS certificates, and data credentials. This is a small snippet of secret kind. So you simply do kind secret, type opaque. You can store username and password in this base 64 coded format. What is a config map? Simple. Config map is something similar to secret, but it stores the non-sensitive configurations such as key value pair. It allows you to externalize your application config from the container image so that the deployment is more flexible and environment independent. A popular question is coming. What's the difference between secret and config map? Very good. So secret stores sensitive data. It doesn't store some non-sensitive data. Encrypted, non-encrypted. Base 64, not encrypted, human readable. Use cases are password, API keys, or such credentials. For this app configs, environment variables, and feature flags. This is very very important. Difference. Mounting, it can be do with new variables. RBAC control, highly sensitive, less sensitive. Default type, there are three type of secrets: opaque, Kubernetes IO, TLS, etc. Just config map. Kubectl command, kubectl create secret, kubectl create config map. Next question. What is Demonset? Demonset is a type of Kubernetes workload that ensures a copy of pod runs in every node. Suppose you have a 3 node cluster. So Demonset will run 3 times, and basically 3 pods will run on each node. So basically, what are the use cases for Demonset? When you have a monitoring agent where you need to do capture the matrices, so like node exporter. Node exporter runs on every node. Log shippers, fluentd, log stash. So it will run on every node to capture the logs. Security scanners, all these other are the other applications requirement for Demonset. Next question. What is an init container? Init container is a very interesting thing. Not everyone is aware. Init container is a specialized container that runs just before your main application, and when it sets, it is used to do prerequisites that are needed or initialization tasks that are needed to run to your container, and it exits before your actual container starts. Run initialization logic, prepare environments, run tasks, and so on. Next question. What is PV and PVC? Another important question. Persistent volume, persistent volume claim. Persistent volume and a persistent volume claim are used to manage storage of your pods so that data persists across pod restart or failure. So it's popularly used with stateful set, right? So this is a persistent volume claim. So I'm saying please have my persistent volume claim of 5 GB with this path as a shared mode, right? So I've asked my worker node to fix 5 GB. Now I will come and ask for 1 GB from that 5 GB, right? So persistent volume claim is something I'm claiming 1 GB from that 5 GB with shared mode. So this is the beauty of, and the moment you do PVC, this will become bound, right? That's it. I think it was a very quick session. We have talked about very small and basic questions of Kubernetes. We'll talk about more complex questions in Kubernetes in our next session. Till that time, do not forget to like and subscribe the channel, and do take care of you. Do to take care of you. And yeah, good day for now. We'll see you in next session of interview questions of Kubernetes. Thank you. Bye bye.